So when you have more than one quantity, when you have a quantity of more than one reactant, you're going to have to figure out what the limiting reactant is, even if they don't tell you to do that, because that's the only way you can find the amount of product. And these are the steps in doing that. Calculate the amount of product that can be made from each reactant. The reactant that gives the smallest amount of product is the limiting reactant. And then state the limiting reactant in the mass of product form. That's the smaller product and the reactant that gave that to you. So 3 steps. So this is a little more involved here. How much molten iron is produced from the reaction of 25 grams of FeO with 25 grams of aluminum? Here we've got our balanced chemical equation, and we're going to use that to organize our information. So they're saying I have 25 grams of FeO, so I'm going to write that here, 25.0 grams. And I also have 25 grams of aluminum. And what's the question? How much molten iron? That's this guy. Now they don't give a unit or a quantity. What do you think they want? They probably want mass. I should rewrite that question. So this is question mark grams. So I've organized my information. This is a mass kind of problem. There's 2 quantities given here. That means I need to do 2 calculations. They're going to be very similar, but I need to do 2 calculations, find 2 masses of iron, and choose the smaller. So this is grams to moles to moles to grams. So 25.0 grams of FeO, grams to moles, moles of FeO, and now we're going to go to moles of product. Don't worry about the aluminum right now, just ignore him. Moles of Fe, and then mass, grams of Fe. So moles of Fe are down here to cancel like that, and moles of FeO are down here, and grams. Same process. This conversion factor is going to be the molar mass. I'm running out of space, so I'm not going to write it out, but 55.85 is the mass of iron, plus 16 for the oxygen, 71.85. Over here on the end, iron, 55.85. It's kind of a sad 5. It's a little better. What's the mole ratio? How many moles of iron? 3. And how many moles of iron oxide? 3. So 25 divided by 71.85 times 3 divided by 3 times 55.85 equals 19.4 grams of iron. That's one possible answer. That's if the iron oxide can all get used up. But then we have to do another calculation with the other reactant. 25 grams of aluminum. It's going to follow a very similar path. This is moles of aluminum, and then moles of iron, and then grams of iron. And what I'm teaching you is not the only way to solve these problems, but it's the one that seems to work best for most of the students. Sometimes students go, I don't know, they get lost, and they over here they start out with grams of aluminum, and they go to grams of iron oxide, and they get all twisted around. Just go to the grams of product that they're asking you for. So you're going to end up with the same unit for both of these calculations. Just getting my units all lined up here. Okay, so grams Grams per mole of aluminum, 1 mole is 26.98. That's just from the periodic table. Iron, 3, and aluminum is 2. And then this last term ends up being the same because it's grams of iron per mole of iron. So 25 divided by 26.98 times 3 divided by 2 times 55.85. Well, that's a little different, isn't it? I got 77.6. Anybody else get that? Yeah. Like, wow, those are really different. Same mass of each reactant, but you get a lot more from one than from the other. That happens. How much product can we actually make? 19.4. So I'm going to box that. That's the amount of product. Does it ask me what the limiting reactant is? No, it doesn't. But what is it? It's a scud. Whichever one gave you the smallest answer, that's the limiting reactant. That gets used up. We would call aluminum the excess reactant. I forgot to cancel these guys out. Oh, I didn't want to cancel the 29. There we go. Any questions? We can also do limiting reactants involving gases. These end up being a lot easier, but they follow the same general process. So let's say we had 5 liters of each of the reactants in this reaction. 5.00 liters of this one and 5.00 liters of that one. Here they're saying, what is the limiting reactant? They're not asking for the mass of product, but how do we go about finding which is the limiting reactant? We find the amount of product. So we're going to find this whether they ask us to or not. So 5 liters of no, and I'm going to find out how many liters of NO2 that would make. So those cancel. The ratio here is 2 no's to 2 NO2s. 2 over 2. It's going to end up being the same. 5. If we start with 5 liters of oxygen and are able to use all of it up, liters of NO2, liters of no, 2 NO2s, 1 O2. Thank you. Yes, I am screwed up again. See? Isn't that a fun game? Yeah. It's better than falling asleep on your hand. Units. Okay. 5 times 2 is what, 10? I think 10 liters. What's the limiting reactant? No. No, that's the answer, not I'm telling you you're wrong. Nitrogen monoxide. It gave the smaller answer. So, good grief. Come on, iPad. Entering. Nitrogen monoxide is the limiting reactant. Any questions? Limiting reactant problems, take the mass or the volume, whatever they give you of each of them, find how much product can be made. The smaller is the answer. The limiting reactant is the reactant that gives you the smaller amount of product.